Greetings everyone, we are from Group B and my name is Jasmine Wang Taiwei. So I would like to start on discussing the control chart for variables, which is the control charts for mean and range using R programming software. So the example given here about a process by which coils are manufactured. So it is given that there are 25 subgroups and the samples of size 5 are randomly selected from the process and the resistance values of the coils are measured. I found that there is a typo for the range of the last sample, which is the range should be 3 and not 4. So let us start to construct the control charts using R. So first, we need to import the data set of this example from text file like this. And when we print it out, we can see our data here. Next, we have to use the QCC package, which is for quality control chart and statistical process control. The R chart is analyzed before the X bar chart to determine the out of control situation. So now, let R chart equals to the QCC package, our data, and the type of control chart is R chart. And sigma equals to 3 because the control limits for R chart is equals to R bar plus minus 3 sigma. So we get our R chart here. The number of group equals to 25. The center line is 3.88. Standard deviation equals to 1.6681. The lower control limit is 0, while the upper control limit is 8.204142. We can see that number beyond limits equals to 2 because these two red points are beyond limits as they lie above the upper control limit. So we can say that R chart is not in control. Now let us see also the X bar chart. We use again the QCC package, our data. The type of control chart is X bar chart and the number of sigma is equal to 3. Now we get our X bar chart here. The center line equals to 20.936, lower control limit 18.69801, upper control limit equals to 23.17399. And we can see that all the points in X bar chart are within the control limit. Therefore, we can say that the X bar chart is in control. Because of R chart is not in control, we explore further to see what is the problem, and we find that the range for sample 13 and 19 are suspiciously high. Since the R chart is out of control, then the limits on the X bar chart is not meaningful. To solve this problem, we need to eliminate sample 13 and 19, and we calculate X bar, R bar, and the control limits. Then we determine again if the charts are in control. Now we try to eliminate sample 13 and 19 from the dataset. We can see that sample 13 and 19 have been removed. Now we put again the new R chart. So we can see our new R chart here. The number of group become 23 after we remove the sample 13 and 19. Center line become 3.304348. Standard deviation become 1.420614. And lower control limit is still 0 and the upper control limit equals to 6.986943. We can see that all the points in the new R chart here are within the control limit. So the R chart is in control. Now we see also the X bar chart. We use again the QCC package. Now we can see our X bar chart here. Again, the number of group become 23. The center line become 20.86087. The lower control limit is 18.95492 and the upper control limit equals to 22.76682. Again, all the points in the new X bar chart here are within the control limit. So we can conclude that the X bar chart is in control. So we can say that the process is now in control. So to ensure the process is in control and has reliable estimate of centering and variability, we need to monitor for several more days to make sure it remains stable. We need to repeat this process until the charts indicate an in-control process. So in industry, the R chart is used to monitor the process variation, while the X bar chart is used to monitor changes in the mean of a process at regular interval. So these control charts are very helpful to keep the process in control. So that's all for the control charts of mean and range. Thank you.
Assalamualaikum and hi everyone. My name is Nadia and I'm going to continue this video by presenting how to plot S chart and the X bar chart. Okay, so based on this question, I firstly want to plot the S chart. So I will copy the values of given standard deviation in this question from sample 1 until sample 20. Okay, so I will firstly declare the values of standard deviation from the question in RStudio. Okay, and then next I will also declare the value of upper control limit. Okay, so the value of upper control limit for this question is 10.85. I got the value by calculating it using the formula of upper control limit of S chart. Okay, so the value of upper control limit is 10.85. Okay, and then I will proceed to declare the value of lower control limit, which is 0, also based on the formula given of S chart. Okay, so after I have inserted all of these required values, I will then plot the graph of S chart. Okay, so this is the S chart for the question. So as we can observe in this graph, the process is in control because all of the data is within the limits, is within the upper and lower control limits. Okay, so now that we know that the process is in control, we can now proceed to plotting the X bar chart of the process. Okay, so firstly, I will insert the values of X bar given in the question. Okay, so the question gave us the values of X bar, or also known as sample mean. Okay, so I will insert the values of X bar in RStudio. Okay, and I will declare it, run it. Okay, and then I will proceed to declare the value of upper control limit, which is 44.98. So I also obtained this value by calculating it using the formula, but this time using the formula of X bar chart. Okay, so the value of UCL is 44.98, and then the value of lower control limit is 29.38. Okay, so by inserting all of these values, I can now plot the X bar chart. Okay, so this is the X bar chart that we have obtained using this software. Okay, and as we can see as well in this chart, the process is in control because all of the values of X bar is within the limit of upper control limit and lower control limit. Okay, upper control limit, which is 44.96, and lower control limit, which is 29.38. So now we can conclude that the process is in control and we don't have to do any alterations or elimination in the data. That is all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Farah Adiba and I'm going to explain on how to do the P chart for question 1 by using the RStudio. So the first thing is we need to open the RStudio and install the QCC package. So after we install the QCC package, we start with the coding. The first coding is we need to write pchart equal to data frame, as I did, and then we write pchart equal to edit pchart. So after that, a table will be shown, and then we insert the value, all the values for the question. So after we insert the values, alright, then we name the table as sample, S, N, and also P. So after that, we want to see how the progression of the table. We write pchart. So the table, after we name it and insert the value, we can see it below. We can see, and then after that, we write p.data equal to C, the value of X. Every value of X we insert 4 to 5 and so on. And then after that, we write QCC p.data type, which is P, and then size is 50. We press enter and we got the chart here. Okay, so we can see the control limit is 0.072, lower control limit is 0, upper control limit is 0.182. So we can see that this data is out of limit. One of the data is out of limit. So this chart is not in control. We need to remove this data, which is at the 18th. So we need to do another chart. So we write p.data equal to C. We copy paste everything, but we remove the 18th data, which is 10. Alright. So after we remove, we got the new value, and then again we write QCC p.data type P, and size is 50. So we got a new data here, a new chart here, and everything is in control, in limit. So we got the normal chart, normal data. So we settle the question for question 1, and that's it from me. Thank you.
Hi, Assalamualaikum. My name is Ainur Fitrani binti Amran, and I would like to explain about NP chart. Before that, we go through the question. There are 20 sample and the number of dissatisfied customer, and we have n equal to 300, right? So I like to show you how to calculate manually for the standard deviation, for the upper control limit, for the lower control limit. So for the standard deviation, we use the formula square root NP times 1 minus P. But we need to find P first. So central line equal to NP, right? So equal to 9.2. So we get P equal to 9.2 over 300, N equal 300, and so that we can get 0.0307. So we just insert the value that we get into the formula for the standard deviation, which is equal to square root 9.2 times 1 minus 0.0307, and we get 2.9862. For the upper control limit, we use the formula equal to NP plus 3 times square root NP times 1 minus P. So equal to 9.2 plus 3 minus 2.9862 equal to 18.1586. For the lower control limit, LCL equal to NP minus 3 square root NP times 1 minus P equal to 9.2 minus 3 times 2.9862, then we get 0.2414. The first thing is mean. We need to find mean, which is equal to average. Open bracket and just take all the number of dissatisfied customer, and then we get 9.2, right? So for the standard deviation, we calculate just now, we get 2.9862, right? So for the central line, which is equal to NP, we just type equal $C$1, then we get 9.2, and it can be the same value. We just calculate once and then copy it. Next is for the upper control limit. So we just type C5 plus 3 times $C$2, and we get 18.1586. And for the lower control limit, we just type equal to C5 minus 3 times $C$2, and we get like this. For the lower control limit, we just insert it and take chart, and then we can see the NP chart. Okay, we can see that the graph NP chart is that the process is not in control, right? So we need to find out why this happened. Then we need to delete or remove the data, which is data 13, because it is out of control, and we just delete this row, and then we just change it to 13, 14, 15, 17, 18, 19, and we can see that there are 19 samples, so we can get the new mean and also new the standard deviation. I already calculate the standard deviation, and I get 2.9039, and also we can get all the new for the central line, new of the upper control limit, new of the lower control limit, and then we can get this graph. So this graph is in control. Okay, so that's all from me. Thank you so much.
Hi everyone, let's continue to discuss the control chart for attributes, the control chart for the number of nonconformities, which is the C chart. The C chart is used to analyze some attributes of the process, as it monitors the number of nonconformities or defects of a process based on Poisson distribution. So the example given here, the sample of fabric from a textile mill, each 100 meters square, are selected, and the number of occurrences of foreign metal are recorded. The data of 25 samples are shown in the table. So we are going to construct the C chart for the number of nonconformities using another programming software, Python. So firstly, we need to import the required libraries such as the array processing package, the data frame package, the 2D plotting package, and the mathematical function package. Next, we import external dataset from an Excel file and name it as df, the data frame. And when we print it out, we can see the dataset here. Then we proceed to plot the C chart. We first set the figure size of the C chart, and we plot the non-conformities of the data. And the three lines here represent the upper control limit, the lower control limit, and the center line of the C chart. In C chart, if the lower control limit is less than 0, it is converted to 0. So we put a title of the C chart and label the X and Y axes. After that, we find the values of the center line, upper control limit, and lower control limit. And we round the value off into 4 decimal places, and we print it out. We print the values out. Finally, we detect the points which are out of control to see which points in the C chart is beyond the limits. So in the result here, you can see the C chart is like this. The center line equals to 7.56. The upper control limit is 15.8086, and the lower control limit is negative 0.6886. But since the lower control limit is less than 0, it is converted into 0. So we found that for sample number 9, the non-conformities is very high compared to other sample. And we found that the sample 9 is out of control limit, which is here. So now we have to try to eliminate the sample 9 from the dataset and plot a new C chart. So we let a new data set and we eliminate the sample 9 from the dataset and print it out. We can see that the sample 9 has been removed. Next, we proceed to plot the new C chart, and the same process. We set the figure size and plot the non-conformities of the dataset, and these three lines still represent the upper control limit, the lower control limit, and the center line of the C chart. And we put a title, new C chart, and label the X and Y axes of the C chart. And we find the values of the new center line, upper control limit, and lower control limit, and round them off into the 4 decimal places, and we print the values out. Finally, we detect again the points which are out of control. So let's see the result. We can see that the new C chart is like this, and the center line equals to 7.2083. The upper control limit is 15.2628, and the lower control limit equals to negative 0.8462. And since it is less than 0, it is converted into 0. So we can see that in the new C chart, all points are within the control limit. So we can say that the process is in control. So in industry, certain processes are suitable for monitoring with a C chart. For example, monitoring the number of product returns per day and monitoring the number of discrete components that must be resoldered per printed circuit board. So that's all from me for the C chart. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. I'm Nur Sarato Ameti Asral. So I will continue with the next question, which is for the U chart. Based on this question, actually I need to I will construct a control chart for the number of non-conformities per 100 meter square by using R programming. So let's start programming. First of all, you need to install the Q60 package. For me, I already installed it, so just continue with our coding. For this question, I just need to write all the data from the questions. So first is the amount inspected. We can write as AI equal to C and write all the data here. Here we already write all the data for the amount inspected. Next we write for the number of non-conformity. We can write as NON equals to C and write again all the data given here. To finish write all the data from the question. We continue with the next coding, which is 2 equal to QCC with bracket for number of non-conformities and the amount inspected and the type equal to U. And enter. Here we get our chart U chart for number of non-conformities. So here we can see all the points here, all the groups, 20 groups. We have a 20 sample, so there is 20 groups, and the center is 4.682927. Here, center line for the upper control limit and lower control limit is a variable because they're different each groups. And here we can see there is the red one here because it is out of limit here. So for this chart, actually there is not in control. Make it correct, we need to remove the data for the group 7 here and redo again the same calculation to get the new chart for this question. Okay. So we just copy the same AI, but we need to remove the data for group 7, which is for amount inspected. Group 7 is 2 from here. We need to delete it. And that's for the number of non-conformities. Need to delete the data 20 here. Continue with the same coding, and let's see if we get a new chart here, new U chart for number of non-conformities, and we can see here all of the limits, which is all of the groups here, 19 group because we already removed one of the groups. So there are no points that are of limit, so we can say that these control charts are in control.
Hi everyone, my name is Wong Xiang Yi. Now I would like to explain how to construct U-chart by using Microsoft Excel. Column B to column E is our given data. To construct U-chart, the first step we need to do is calculate the total demerits by using this formula. W1, W2, and W3 is the weight associated with a defect for each respective category, while C1, C2, and C3 is the total number of defects of each of the 3 types for a sample. So this column shows the total demerits for each sample. Next, we need to calculate the demerits per unit, which is D over N. N here is sample size and our N is 10. The third step is we need to calculate the center line by using this formula. U1 bar, U2 bar, and U3 bar is calculated using this formula. The summation of CI means that we need to sum up all the number in column C, column D, and column E, and we will get 9, 74, and 114. While the summation of NI means that we need to sum up all the sample size for each sample. Since our sample size is 10 and we have 20 samples, so our summation of NI will be 200. And the U1 bar, U2 bar, and U3 bar is calculated and shown here. Next, we need to calculate the upper control limit and lower control limit. The sigma here is calculated by using this formula, and we will get our sigma is 3.8739. And this is our upper control limit. And our lower control limit, I will get negative 5.1017. And since it is a negative value, so we just assume the lower control limit to be 0. And now we can construct our U chart. We highlight this data. And this will be our U chart. From this chart, we can know that the process is in control and the upper control limit is here, and this is our lower control limit. So that's all from me. Thank you.